So the first method we learned was the table of values. And I told you table of values, super powerful, because it works with any graph. Question? You've lost your notepad. I have handed out all of mine and my extras already. So next week you can photocopy a new one. Okay, but you look for yours.
Yeah, I'm
sure it'll show up. But for now, you can either choose to sit back and watch, write notes on a different piece of paper, or whatever you think would work best for you. And Nancy? Oh, and next question that I'm asking all my classes. Wow, that's a beautiful ice cube. Did anyone leave their mitts in here? I'm asking all my classes. No? All right, I will keep asking my classes. Okay, here we go. Y equals, oh yeah, so I was saying that we learned our table of values, but table of values is good. It's actually a really quick way for graphing lines, but in everything that we graph, we will also learn some shortcuts that are sometimes fast. And when you have a line in y equals mx plus b form, you have a shortcut available because the b is the y-intercept. The m is the slope. And if you know those two things, you can quickly put a bunch of lines, or sorry, you can quickly put a bunch of points on your line much faster than a table of values. How does it look? Well, we're going to, once we found our slope and y-intercept, we're going to graph our y-intercept, then we're going to use our slope to find more points. And it looks like this. First of all, y equals 2x plus 3. You would know that your slope is 2, which as a fraction is 2 over 1. And our y-intercept is 3, so the very first thing you're going to plug in is your y-intercept at 0.3. Then a slope of 2 means you go up 2 over 1. There's another point. Up 2 over 1. Another point. Up 2 over 1. So you see how we can quickly find points. Then we can label them 2 if we want. Over 1 would be at 1. Up 2 would be at 5. So that next point would be 1 comma 5. And you could draw a straight line through those points, put an arrowhead on the end saying that it continues forever. And we've graphed the line. So very similar to a table of values that you could find a couple of points, but much faster to find the second, the third, the fourth point than plugging things in. Ready for everybody good? Right. Example number 2. Sometimes you're going to have to rearrange, if you want to use this shortcut, sometimes you have to rearrange the formula. The key to knowing that your formula is in the right place is you have y equals all by itself. I have y equals all by itself. The number in front of the x is going to be your slope. So this one's matched up nicely. That m would be -3 and b would be -1. Would I have messed you up? Would you have got it wrong if I wrote it like this? Right? It's the same thing, right? Adding and subtracting doesn't matter where you put like order in your terms, but it might just mess you up just a little bit. So if you add -1 minus 3x, you'd be like, oh, wait a minute, I could put the -3x first and the -1 at the end. It would mean the same thing, but it's good for us to see how things can get rearranged. So b value is -1. So we can go, that's your y-intercept. It's going to cross your y-axis. So 0, -1. Slope is -3. So I can either go, right, -3, you could write that as a fraction as -3 over 1 or 3 over -1. Again, this is your rise, this is your run. So -3 would mean go down 3, positive 1, 1 to the right, down 3 over 1, down 3 over 1. Oops. Perfectly. Through all of those, put arrowheads on the end. That is our line. I'm going to label one other point on here. I had 1, -4. It is not enough to just label your y-intercept. If I label my y-intercept, can you see that plugging in that -1 defines that each of these are going by 1? But I have no indication, if I just label that point, you don't know what your scale is on your x-axis. Because you've just labeled 0, right? If you know this is 0, do you know that you're going over by 1? No. You might be going over by 5 or over by 2s. So when we label our graph, we have to indicate a scale on our graph, both for our y-axis and for our x-axis. If the only point that I labeled was 1, -4, it actually would be enough. Because I've told you what I'm doing along my x-axis, going by 1. I've told you that going down 4 is -4. That would have been enough. So generally, if you label 2 points on a line, you're going to be fine. So it's sort of a good reference. Always label 2 points, then your scale will be shown for sure. The nice thing about y equals mx plus b is if your m is a fraction, it actually doesn't make the question any more difficult. Can you see that m is 2/3 and b is -3? So I would start by going and labeling 0, -3 as my y-intercept, and a slope of 2/3 up to over 3. Up to over 3. Up to over 3. How easy was it to find some more points? If I labeled one of these other points, this point here is 3 -1s. Can I draw a straight line through all of those? Absolutely. Put arrowheads on the end, and we've drawn our graph. What makes this nice over the table of values is with the table of values, right? With the table of values method, we always started with 0 because that was really nice as a y-intercept. That would be no problem. Then what did you almost always tell me to try next? 1. And 1 isn't, this isn't bad, but can you see that if I plug in 1 for x, I'm going to get fractions. I'm going to get 2/3 minus 3, which is going to be -2 1/3 or -7/3. And all of a sudden, that's harder to graph. Not impossible, but it is harder to graph. Where would that be? Right? -7/3, if you write it as a mixed fraction, is -2 1/3. Can you see that this purple point right here is approximately at -2 1/3 more? And matches up. You could use that point, but now we made it more difficult. So the slope in this one helped us find nice points right away. That doesn't always happen though. Sometimes your y-intercept is a fraction. And then you got fractions over and over again. So we can look at that as well. Uh-oh. And you see that this one doesn't have the y equal by itself. So we can't figure out the slope or the y-intercept quickly until we've done that. How hard is it to get y by itself? What would you have to do? Same thing you've done with equations all the way along. I want to move this x. Well, I'm going to subtract x. If I subtract x from that side, I'm going to subtract x on this side. Now, most of you would probably normally write on the right-hand side 2 minus x when you subtract x. Okay? Are you okay if I write the minus x? No, I want to use minus x first and plus 2 after. Why would I do that? Now it matches up with y equals mx plus b. Yeah, what was mb? Can I just do this? No. Is it just a dash? What? It's -1. Right? The 1 isn't written, but it's like invisible there. And then the b value, 2. Oh, so much fun graphing lines. I hope are you enjoying drawing these lines? Kind of fun?
Well, then,
No?
2 plus,
Oh, it's fun.
2 plus -1 is 2 though. Just m
Okay.
if m is.
If m is -1, which as a
it's
fraction,
minus that's on
that's
the x.
-1/1, so you can think of that as your rise,
Never
and
mind,
this is
sir.
your run. Right? You sort of always have, even if it's a whole number, you have to change it to a fraction. We've got b as 2, so that means I've got this point at 0,2. Rise and run of -1 means that I can go down 1, over 1, find another point. Down 1, over 1. You see, you can find those points really easily and draw a straight line, put arrowheads on the end, and we've got our graph. I need to label one more point, so I'm going to label this one 1, 1. Label my 2 points, and I found my graph right away. You can always check the point, right? We found 1, 1. If I plug in 1 for x and 1 for y, does it work? 1 plus 1, 2. Again, what you have to be able to do is say, I can switch. What we're trying to do here, we're trying to switch from equation to graph. Right? Sometimes we switch from equation to table of values to graph. Sometimes we switch from equation to points to graph. And now we're trying to just go, can we go from the equation right away to the graph? And we can do that by using the slope and the y-intercept. You feel like you're getting good at this? Is this? What are things that are hard so far for you? Any things that are confusing? We're doing okay? All right. Okay. Again, this one's harder. Oh my goodness.
Well, when x is 0, then y is,
So you're going to a point. So sometimes you might look at this one, you might say, I like to do table values instead. Okay? It wouldn't be bad. Someone just said, hey, when x is 0, what's y?
3. Now you're y intercept. Sure, you're x.
You can find that. Okay? Any other ones that would be easy to figure out? Oh, this is not hard. Y is 0. X would be 9. So it's true that the table of values here might be really good. And in fact, if you found those 2 points, you have 0 and 3, and 9 and 0. Would that be enough to graph your line? Absolutely. 0 and 3, and 9 and 0 is 2 points. Guaranteed to have enough, you could graph your line. So we could do the table values in this one really easily. Y equals mx plus b is a little bit harder because it's not in the y equals form. But you will get equations that are going to ask you to rearrange things to make it work. So if I wanted, if I wanted this y to be all by itself, can you see that you'd have to first move your x over to the other side? Okay, so I'm going to minus x on both sides. That would give me 3y would be what's left. I'd have, I'm going to write the minus x first, plus 9. Now, how do you get rid of the 3? Divide by 3. So that means I divide this whole side by 3. I divide this whole side by 3. And you would get the following. Y equals, this is good. Now, dividing that whole side by 3 means the x is getting divided by 3, and the 9 is getting divided by 3. So I could write negative x all over 3. I could also write that as that. Does that make sense? Because that's just a different manipulation. That means the same thing as just the x divided by 3. Why did I write it like this? So that I could see my slope. And then 9 divided by 3, that will be 3. According to this, my slope is negative 1/3. My y-intercept is 3. Question?
So basically at the start it's showing x-intercept?
Basically at the start, it's just a different form. You could easily find the x-intercept because you'd have to plug in 0 for y, but it doesn't necessarily do that. Okay, it's not for sure that that's always the x-intercept, depending on how the equation is. But you can always easily find an x-intercept by plugging in 0 for y. You can easily find a y-intercept by plugging in 0 for x. So graphing a line using the intercept is a great strategy because they're usually easy to find. Because you got to plug in a 0 for something, your math is going to be easy after that. Okay? But if you had first rearranged it to get it into y equals mx plus b, you could label 0, 3, which we have already. Can you see a slope of negative 1/3? This would be your rise. This would be your run. So I'm going to go down 1 over 3, find another point. Down 1 over 3, find another point. Down 1 over 3. Woo! Little smiley face on that point. We'd already found that point. And so we can draw a straight line through all of those points. Perfect. It's actually very interesting. One of the places where a lot of grade 12 students are having difficulty in grade 12 math right now is because they learned lines during COVID. And they had to learn it online. And everything that people learned during COVID was just sort of like mediocre learning. Probably a good description. Right? You weren't pushed to learn things quite as well as you should have. And so you didn't learn them quite as well as you should have. What would that be for you guys? Fractions? What for math? What were the main things that were 2 years ago for you in grade 8? Multiplication, fractions, integers. But luckily we redo those in grade 9. So you guys, I think, are in a good position for doing well in math all through high school. As long as you decide to work hard, you guys are this year in math. Oh. Okay. You can use technology to graph lines. And I'm going to show you, some of you already have graphing calculators. So if you have a graphing calculator, on your graphing calculator there's a y equals button. On that y equals button, if you push it and your calculator freezes, you just wait. again. Can you wait? What was the equation we just graphed? We just had negative 1/3 x plus 3. So I can go to my calculator and I can write negative 1 divided by 3. There's an x button, x plus 3. Write it that way. If you have even the fancier one where you get to do the fractions, some calculators even let you write negative 1 divided by 3, x plus 3. And you hit the graph button, it draws the graph for you. Now, if you do not have a graphing calculator, then you can go to the internet or your app store and download the following app, which is amazing. Desmos is what it's called. So if you type into the App Store Desmos, or if you type Desmos into Google, you have an app that's a graphing calculator. Obviously, it's a very fast app. Not that my computer is. And in the little space, you can just write y equals, of course, there we go, negative 1 divided by 3, x plus 3, whoops. And it changes things to fraction form right away. It's beautiful that way. You can write it exactly as you would want to see it. Negative 1 divided by 3 changes it to a fraction. That's exactly what I want. And there's the graph. And what's really nice about Desmos, you can click on points and go, oh, there's my x-intercept. That was easy. Oh, there's my y-intercept. That was easy. It finds those by just pushing on them really quickly and really easy. Very powerful stuff. So if you can, on your phone, if you own a phone, download the Desmos app, because sometimes you'll want to verify stuff, and this is very quick and easy to verify. Okay. So we saw this in our last example, that our x-intercept and y-intercept are two special points, and they can often be used to find your graph quickly. They're super easy to find. The y-intercept, that's your b value if it's in y equals mx plus b, but you can always find it by plugging in x equals 0. And even in, I mean, is it pretty obvious in y equals mx plus b if you plug in 0 for x, what's y going to equal? B. Right? But you can plug in 0 for x even if it's not in y equals mx plus b form. And then if you get y by itself, you've solved for your y-intercept. Similarly, your x-intercept is when y is equal to 0. All right. So it talks a little bit about how to do it on the graphing calculator. If I want to find my x-intercept or y-intercept on my graphing calculator. So for those of you that have a calculator, you can push the second button, and then above the trace button it says calculate. It can calculate a bunch of different things. One of the things it can calculate is a value. You push that and say, what one would you like to find? I want to find when x is 0. I push that. It tells me y is 3. I could have also done x is 1, and it tells me y is 8/3. So we can find all sorts of points, but we generally use value to find a y-intercept. If you want to find the x-intercept, I'm going to tell you that another word for an x-intercept is a 0. So on the calculator it says, you want to find the 0? Yes, I want to find the 0. And on the calculator it says, move your little cursor thing I'm gonna get really close to, can you see that your x-intercept is right about there? Well, we already know it's at 9. If I'm a little bit to the left of it and push enter, my calculator draws a whole line. Some graphing calculators just draw the arrow. Then it asks me to go to the right side of it. I go to the right side of it. I push enter. It draws another arrow and another line. Then it asks me to guess. I think it's going to be right there. When you push enter again, it finds it for you at 9, 0. Desmos is a lot easier. You just go ding, and push your finger on it and it tells you right away. The graphing calculator says, I want you to go to the left side and to the right side and then figure it out. And the reason for that is the graphing calculator has an algorithm to find it. If on the left side my cursor was on a positive y value, on the right side is a negative y value. What the graphing calculator does is it says, well, let's go halfway between. If halfway between is positive, then I'll use 2 new points, and then I'll keep going halfway in between until I'm satisfied that I'm close enough. So the graphing calculator has an algorithm. So does Desmos, but Desmos' algorithm is more interactive, and you can just push the button. Yes?
This has nothing to do with right now, but if we were gonna try to find the area of a triangle and we have 3 of the points, we just find the distance between all sides.
So if you want to find, yes, you want to find the area of the triangle of all 3 points, you find the distance of all sides, have to figure out which one is the 90 degree, so you have the height and the base, and then find it. I was so tempted, after you asked the question that has nothing to do with what's on here, I was going to say, I'll give you an answer, but it has nothing to do with the question.
It's so neat.
I didn't record that. I turned that off. Okay, so you have the worksheet at the bottom here, and we have 25 minutes left.